Just what a beautiful story it is, and what the big breakthroughs were with drug development, and how, at one point it was like all you could give people was prednisone and you couldn't save anybody. And then, you had other drugs like cyclosporin that were introduced. But then you get into this third generation of amazing drugs like rapamycin that took organ, preservation to a higher level.
Secrets of rapamycin revealed. From its exotic origins to its resurgence as a potential anti-aging compound, rapamycin continue to fascinate. Eastern Island, where the rapamycin-producing bacterium was first isolated, is best known for the 887 ancient giant statues called moai that line its shores. The history of the natural product rapamycin begins over 50 years ago in one of the most isolated places on Earth. Through the curiosity, commitment, and hard work of scientists, this compound has led to several approved immunosuppressive and anti-cancer drugs. It also helped uncover the science of aging. On the snowy November day in 1964, a group of about 40 doctors and scientists were on their way to Eastern Island, a triangular spot in the South Pacific that is 2,200 kilometers from its nearest inhabited neighbor. Their goal? To study a group of people, their heredity, environment, and common diseases who lived in these uniquely remote places. As scientists have established, no one could predict that the most valuable find of the Canadian expedition would be made from a piece of bacteria that has settled in a soil sample from Eastern Island. George Nogrady was not looking for a cure when he divided Eastern Island into 67 lots and took soil supplies from each of them. A microbiologist at the University of Montreal was trying to figure out why the islanders don't get tetanus, a bacteria infection often found in areas where horses live. Not only were there more horses than the inhabitants of the island, its inhabitants went barefoot. It's well known that this is an easy way to pick up tetanus spores. One of the whales harbored a bacterium capable of producing rapamycin, a then unknown microcycling compound with many medicinal properties. The molecule has been found to be a powerful immunosuppressant that can also stop cancer cells from dividing. Researchers have spent decades elucidating the form and function of a compound and its target, a protein known as mTOR. Now, almost 50 years after the Canadian expedition, rapamycin and related compounds, dubbed rapologists, are finding new life as possible anti-aging pills.
So rapamycin is a drug that is a naturally occurring antifungal agent made by a bacteria that was discovered on Easter Island back in the 1960s.
A rocky start. When scientists look at the antifungal effects of rapamycin, they found that the compound is not only a powerful immunosuppressant, but can also prevent cell multiplication. Scientists have also found that rapamycin has amazing activity against solid tumors. However, all works on rapamycin was abruptly stopped in 1982, as rapamycin proven difficult to convert into an intravenous drug in clinical trials. The project was closed. From a practical point of view, rapamycin was the loser. The remaining supplies, isolates, and rapamycin were cataloged in the Ayers library and essentially forgotten by the company. But Segal hadn't forgotten about rapamycin. He was convinced that this material was extremely viable in saving human life. Before Ayers closed its Montreal factory permanently, Segal packed the bacterium into several vials and took it home, where he put it in a freezer next to the ice cream in a package labeled "Do not eat it." When it was time to move to Princeton, Segal's son, Attia, was called home from college to help him. He was instructed to buy dry ice to fill the freezer with valuable bacteria. I sealed the freezer with duct tape so that the removers could not open it, he recalls. The bacterium remained in a Segal family freezer for the next 5 years.
At the time, as his son Ajit tells the story, who I've gotten to know a little bit, he felt he had basically come onto the biggest blockbuster cure for athlete's foot the world was ever going to know. And right about that time, the company he worked for closed its Montreal headquarters, actually laid many people off, ordered the destruction of all non-viable compounds, and shipped him off to New Jersey. In one of the greatest acts of scientific fortuity, he did not follow orders, and he instead stuck said rapamycin into a little mini freezer that he and his family transported to their new home in New Jersey. They kept it in the freezer for many years until ultimately another drug company purchased the company he worked for. And the new management said, "Hey, anybody working on anything interesting?" He said, I'm working on this thing interesting that I haven't looked at in a few years. And they said, "Bring it out." Out came rapamycin, which he named. It quickly became clear that this had remarkable anti-proliferative properties. So it could stop things from proliferating. And in particular, it was very effective at making a certain type of lymphocyte. So 99, this drug comes on the market for organ rejection. And about 12 years later, a study gets published by Rich Miller, Randy Strong, and colleagues as part of what's called the Interventions Testing Program, or the ITP, which is an amazing NIH-funded program that tests molecules that are believed to have a shot at enhancing longevity. And it does so in a really, really rigorous way, probably the most rigorous way we can test small animals. I've interviewed Rich Miller as well. Probably one of my 5 favorite podcasts in terms of like nerding out on all of the molecules that can potentially impact longevity. And rapamycin was in many ways the poster child for the ITP program because, first of all, it's hard to get anything to live longer. Second of all, when they were making the formulation for the rapamycin to feed the mice, and these were very special mice. These were not your typical crappy lab mice that have no bearing whatsoever to real animals. These are a very special type of mice that are much more akin to real animals. And that's a very important distinction between what happens in 99% of mouse research, which is almost inapplicable to humans. And it's why so many drugs that get tested in these, B6 mice and things like that, show some marker of success, and they become wild failures beyond the mice. But this was different. They had trouble getting the formulation to work. And by the time they finally did, the mice were like 20 months old, which means they're almost at the end of their life. They're like 70-year-old, 65-year-old mice. And they contemplated just scrapping the experiment, but they were like, screw it, let's just run it late. So they started feeding the treatment group with rapamycin, and the placebo group get to continue eating their regular chow. Lo and behold, the rapamycin group, despite initiating treatment so late in life, had a staggering improvement in lifespan. There's been so many ITPs that have replicated this, I don't want to misquote it, but it's something to the effect of like a 17 or 19% improvement in the males, or in the females, and 11 to 12% in the males. And remember, the ITP uses a very rigorous way of assessing this, which is they're taking a look at the remaining life. They're taking a look at total life, not just remaining life. So it's an even higher bar to clear how much lifespan elongation happens. They, of course, immediately went and repeated the study, administering the dose when they were younger, and saw an even greater response. This has been repeated over and over and over again. And to my knowledge, there is not a single animal study that has tested this hypothesis that has not found this result. What is also interesting is when looking at other markers, other interesting things such as vision and hearing and other markers of health span, we continue to see improvements in these things for animals as well. And as I think we even spoke about before, a guy named Matt Kaberlein, who I'm just interviewed for a second time for the podcast, has been studying this in companion dogs and looking at heart function, because as you know, basically two things kill companion dogs primarily: heart failure and cancer. And so the question is, what would you be able to do to mitigate especially heart failure, congestive heart failure in dogs, especially large dogs, which are more susceptible to this? And again, the results, though the research is limited because there's not an enormous interest in funding this research, and it's expensive to fund research in dogs that live so long, it's all pointing in the same direction.